Okay, so we got these sets on the board. This is in your notes. This is what we were using, one of the things we were using last time. So just going to start off with a couple warm-up problems, just to real quick review the stuff about sets we talked about last time, the operations. So here we go. I'd like you to please just do these following operations, and we'll see how life goes. So I'd like you to do this. And then let's do, I don't remember if we did these last time or not, so some of them might be the same. Another minute or so, make as much progress as you can. Ask whatever questions you need to, please. I want you to do great on this first test you're going to have a week from today. Yes.
Is the couple on the wall, is that asking for the intersection of C?
It's a letter N. Sorry, that's bad penmanship. All right, so this first one right here, D with a little apostrophe on it, what does that stand for? The complement, yes. And what is the complement? Perfect. Well said. Everything that's not in the set. Okay, so here we go. D is 5, 7, 9, 10. So the complement is going to be everything that is not in that. So 1, 2, 3, 4. 5 is in the set, but 6 is not. 7 and then 8. So you should have these 6 elements in there. And remember, the nice, easy, quick check for the complement is when you smush together, when you union, we didn't have that word when we talked about it, but when you union the set and its complement, you get the universe. Okay, you should have everything, so you can count it up. What does this symbol stand for? Union. What does the union say to do with my 2 sets? Bring them together. Yes, just list everything that's in both sets. I've got 1, 3, 4, 5, 7, 9, 10. Questions so far? If you've got a question, ask it. Do not be shy. Okay, I love questions. I want to help. What does this symbol mean? Intersection. What does the intersection say to do? Yeah. What was that? Yes, shared elements. Perfect. Great lingo to use there. So B intersect D. It looks like they just share one element, which is 7. After we cleared up my penmanship problem, when I have an N out here and whatever set I'm dealing with in here, what is that asking for? The cardinality, which is just that's a fancy word for the number of elements in the set. So the number of elements in C is 3. By the way, we've only seen, I know it's in the homework, but I don't know if you've gotten there yet. We've only seen the cardinality used with something like this. I can't ask a question like this. I could say, what is the cardinality of something we've already done? So B intersect D. Okay, so you can put other things in here, whatever this set is. And so we've just done B intersect D. So what would the answer to this problem right here be? 1. Yep, it's right there. It's that set right there. Great. Okay, just wanting you to be familiar with the different uses. The last one, I don't remember if we talked about this in our last class or if it was the end of the class before, but either way, it's good review. How many subsets are there of B? If I asked you to list them, which would be mean, so I won't. Okay, but if I did, how many subsets would you have in your list? The mass, I'm sorry, what'd you say? Perfect, and I think you said the same thing, but I've got the air conditioner here and masks, and then I've too much loud music, so anyway, sorry about that. So yes, 2 to the 5th power. It's always 2 to whatever the cardinality of the set is. So B has 5 elements on it, and then you take your calculator, 2 times 2 times 2 times 2 times 2 is 32. It's okay. Any questions about these? This brings us up to date with what we talked about set operations. I told you there were 5 set operations. We talked about 3 of them in our last class. So we've got the 2 remaining, and then just a couple other little things to mop up in this third section. And then we'll go into the 4th section. I don't know if we'll get all the way through, but the 5th section in this chapter is very short. So whatever we don't finish today, we'll finish with that last section, and we'll be good to go for this week. Okay, so I'm going to go ahead and erase these. All this is in your notes now if you want it, or it's going to be on a video later if you want to rewatch. If going through this class one time is not enough, you need a little more of the perkster. So the 4th set operation is called set subtraction. The symbol for set subtraction is the same for arithmetic. It's just a minus sign. And here's my Venn diagram. Remember, I gave you a sheet of Venn diagrams the last time we were together. If you need one, I have one. Here's A. Here's B. And what set subtraction is I'll give you the definition, and then I'll tell you a nice, easy way to remember this. What we do with set subtraction, if I have A minus B, then what I do is I start with set A, and then I take out anything shared with B. Yeah. Anybody else? So set subtraction, if I write A minus B, what that means is I start with set A, whatever the first set is, whatever letter that is, you start with that set, and then you take out anything that it shares with the second set. Another way that you can think about this is when you have A minus B, what I want is I want the things that are in set A only. So on my graph, right here on my Venn diagram, here is set A. I'm just going to shade it this way. Here's set A, but then what I'm going to do, I'm going to erase this time. Okay, you got a question? Okay. Just have a look on your face. Just want to make sure I'm not just sliding through something. So here's set A. What is the stuff that it shares with set B? The stuff in the middle. So in set subtraction, what you're going to do is you're just going to say, okay, I'm getting rid of this stuff right here. And so what you're left with is you're left with this piece. Now, if you've already shaded and you're using pen, then just do this. Then what you're left is this piece that looks like an apple that has a bite taken out of it, right there. That is the set subtraction, A minus B. And we started with the full circle, and then we sloughed off anything that was in the part that's shared. How this looks with our sets over here that we've been following along with all of our examples. Everybody caught up? Can I erase this? So for instance, let's do A minus B of these sets over here. And I'm going to tell you the most common mistake so that hopefully you will avoid that common mistake. So set A is 1, 2, 3, 8. The subtraction of these sets can be no bigger. It's never going to be a bigger set. Okay, so this is the biggest that the set can be. So what I'm going to do is I'm going to go through and I'm going to say, okay, anything that A shares with B, I'm going to subtract. So 1 is in A. Is 1 in B? Throw it out. 2 is in A. Is 2 in B? Okay, we'll keep it. 3 is in A. Is 3 in B? Right there. So yes, so we're going to throw it out. We throw out anything that they share. And then 8 is in A. Is 8 in B? Yes, so we're going to throw it out. So the only thing that's left when I start with set A and then I subtract off set B is the element 2. Now I am certain somebody has this question, because it's a question every semester and it's the most common mistake for set subtraction. The question is, okay, we have A minus B, but what about these elements 6 and 7 that are in B? What do they do? And the answer to that question is absolutely nothing. Okay, you start with A, and all you do is take out the stuff it shares. It doesn't matter if there's extra stuff in B, okay, when you're doing A minus B. So we're going to practice this a couple times because this sometimes is the hardest one for students to pick up on. Yes.
Well, now since I've seen it, will you ever have a follow-up question? A universe subtracted or something?
You could take the universe and subtract something, and all that's going to be left is what's the complement of that something. So yeah, it's just going to be the stuff that's left over. So it would be another way to write the complement. Okay. So that's not a stupid question. It's a fantastic question. Here's what I would like you to do, please, is I would like you to, with these same sets, do B minus C. So remember, you're starting with B, and then you're taking out anything it shares with C. Here is B. Okay, the first set is always what you start with. Okay, that is all the possible elements of your answer. And then we are going to take out of B anything that it shares with C. Anything that C has that's unique to itself has no impact on this problem. So here we go. Here's B, 1, 3, 6, 8. So what am I going to do with the 1? Keep it or throw it out? Why am I throwing it out? It's in C as well. Goodbye. The 3, am I keeping it or am I throwing it out? Why am I throwing it out? Just asking you to repeat that so hopefully it clicks in your brain. The 6, what am I going to do with it? Oh, yes, we are. The 7, what am I going to do with it? And the 8, because they are not in C. What am I going to do with the 4 down here that's in C? Nothing. It doesn't impact the problem at all. Okay, so 6, 7, and 8. Fantastic. There you go. Want you to do, we did A minus B, but I just want to see, is it the same thing if I flip it around? So what I would like you to do, please, is start with B, and this time subtract A. So remember, whatever set comes first, that's what you start with. Okay, that is your possible elements of the answer. That's already in your notes, so you don't have to write that down. Unless you weren't here last time, then you do. So B minus A, I start with set B, it's 1, 3, 6A. I'm getting rid of anything it shares in A. So here we go. What am I going to do with the number 1? Toss it, because it's also an A. What am I going to do with the 3? Toss it, because it's also an A. How about the 6? Keep the 7, because they're not in A. And then last but not least, what am I going to do with the 8? Toss it, because it's also an A. Excellent. Sounds like you're getting some good feedback there, but if you have a question, please do not be scared or intimidated. Questions are great. It means you're learning. That is already in your notes, as I mentioned, so you can just refer to when we wrote that on the board last time. So what I would like you to do from here is I would like you to please tell me what B minus A is from that. We're starting with B again, and then we're subtracting the stuff in A. So here is set B, circling it. We can see all the elements, but what's the stuff I'm going to subtract from set B? What's the stuff that is not part of this answer here? The middle. What is in the middle? The F, the C, and the J, right? So that's the bite out of the apple that we're taking. So what is left? After I look at set B and then I subtract off that stuff you just told me, what's the stuff left over? Fantastic. And remember, when you're looking at the picture, another way to think about that is the way we can think about that is what's the stuff that is in B only? Okay, stuff that's only in B, that's not shared, is the stuff that's in this moon-shaped thing. We doing okay with the subtraction? I've got two more things from this section. I've got something dealing with cardinality that we're going to talk about next, since we've got this picture on the board, and then I've got the fifth and final operation of sets that we are gonna deal with. What I would like you to do is this. Using the picture, shouldn't take us too long. I'd like you to answer these three questions right here. What's NA? What's NB? And what's NA union B? What did you write down as the answer to the cardinality of A? Heard two answers. I heard 2 and I heard 5. Okay, one of those is the cardinality of A, one of those is the cardinality of A only. Okay, so A, remember, I've only said A, I've not given you any other details. So that is everything that's in the circle A. It does not matter what else it's in. So that would be 1, 2, 3, 4, 5. Okay, if I said what's the cardinality of stuff in A only, or the cardinality in the subtraction of A minus B, you'd be exactly right. The stuff that's only in A is right here. But the whole circle, don't worry about, I did not say anything about B, so don't make any assumptions. Use that whole circle. Okay, so the number of elements in A is 5. Okay, so let's try this. What's the elements, or excuse me, what's the cardinality of set B? Okay, in that case, it's 7. And then what's the cardinality of the union of these two things? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here's why I ask this. Okay, there's a little bit of trivia that'll be good for us to remember. This will come back and impact us. There's a slight relationship between sets and probability in a couple of areas. Not that whether you do well or not do well in the set stuff is going to affect you then, but there's something that will come back to be very relevant to us when we talk about probability. So let me ask you this question. You already told me that the number of elements in A union B is 9. Is that equal to, okay, because remember the union is what I get when I smush everything in A and B together. So is that equal to the number of elements in A plus the number of elements in B? No, because the number of elements in A is 5 plus the number of elements in B is 7. That's 12. The number of elements in the union is 9. Okay, so why is that? Why, since the union is joining the two things together, why isn't it just I can add the cardinality of the two sets and get the cardinality of the union? Excellent. Well said. Perfect. So what I was just told is, okay, here's set A, and it includes F, C, and J. And then here's set B, also includes F, C, and J. So when we count the cardinality of the two individual sets, we're counting those twice. So this is something that'll be good to remember. There'll be a couple homework problems on this. I may or may not throw one on the test, but if I need to figure out the cardinality of the union, then I take the cardinality of the first set plus the cardinality of the second set, but then I have to subtract the stuff that I have double counted. The stuff that I double counted, how do I describe this? We just talked about this, so this is just another way for me to help you review. How do I describe this football-shaped thing in the middle? What's going on there? That's the intersection. Yeah, beautiful. Well said. So I'm going to subtract the number of elements in the intersection because we count those twice. So a typical problem that you'll see when you are just a problem to help you familiarize yourself with this little bit of trivia is the following. Okay, if the number of elements in A is, let's say, 7, and the number of elements in B is 11, and the number of elements in A union B is, let's go, 14. So I've just made that up for this problem, because all we're going to do is we're going to use this data to familiarize ourselves with that formula right there. If the number of elements in A is 7, the number of elements in B is 11, the number of elements in the union I know is 14. Here's what I want to know. How many elements do they share? What's the cardinality of the intersection? So just to give you a little hint on what to do, you're going to take the values, you're going to plug each value in the appropriate place over there, and then solve for what's left, figure out what's left over. So I'll give you a minute to see if you can figure that out, and if you can't, that's okay. We'll do it together in a moment. All right, so I'm going to put the appropriate information in the appropriate place, and then we'll solve for what's left over, what I don't know. Do I know the number of elements in the union? Okay, 14. I'm going to put a 14 right there. Equals. Do I know the number of elements in set A? Yep, 7. Plus, do I know the number of elements in set B? Minus, do I know the number of elements in the intersection? No, that's what I'm looking for, right? So if you don't mind a little algebra, put an X there. If you are scared of X's, then put a question mark there. Just put a little X. In this class, this is the highest level of algebra you have to know how to do. Every once in a while, you'll have to solve an equation. Okay, so if you don't remember how to solve equations, it's been a long time since you've done that, see me after class. Okay, I've got plenty of videos on YouTube that I use in my intermediate algebra class that'll get you up to speed real quick on solving some basic equations. Okay, so I'm going to go ahead and do this now. We're going to figure out, and probably with your calculator, you can figure it out, but I'm going to collect my like terms. 7 plus 11 is 18. When I solve an equation, I like to have my variable on the one side, all the values on the other. So I'm going to subtract the 18 and put it on the other side. 14 minus 18, your calculator is going to tell you that that's -4. On the other side, I'm left with -x. And the last thing to do is I'm going to divide both sides by -1. And when I do that on both sides, a negative divided by a negative is a positive. So I end up with the value 4. So the number of elements in the intersection is 4. Just a little exercise to help us get used to this, to hopefully remember this relationship that when I'm dealing with the union, I've double counted some elements, and so I have to subtract off the ones I've double counted. Last thing, there's a question about anything we've done: complement, union, intersection. We set subtraction. We talked about the cardinality of the union. If there's a question about any of those things, let me know. I'm just going to keep rolling forward unless I see somebody raise their hand with something that is unclear, or we'd like to do another example of whatever. You're the ones that have paid the money to be here. I want you to get your money's worth. Last thing, the last set operation is called the cross product. There's actually a couple of different types of products with sets, but we're just going to deal with this one type, the cross product. Okay, the symbol for the cross product is an old school multiplication symbol. I'm going to define a couple of small sets, okay, because I don't want this to be too much of a labor, but I want us to understand what's going on. So I'm going to define set A as, let's say, little a, little b, little c. And set B is going to be the numbers 1 and 5. Nothing special, nothing magical, nothing real creative, because we're going to have to do a little writing, and so I'm not using sentences or anything like that as my set elements. Okay, we're just keeping it nice and simple so that we can talk about the cross product. So when I do the cross product, the order matters. Okay, I'm going to do A cross B, and then I'm going to have you flip it, and so that you can see the difference. And then we're going to talk about the cardinality of the cross product, because that will have application for us later in the class. A cross B. Here's what the cross product is. Here's my set, my squiggly. And what you're going to do for the cross product is you're going to take an element from A and an element from B, and you're going to make an ordered pair out of it. If you remember ordered pairs. If you don't, I'm about to show you what an ordered pair is. So what that means is I'm going to take an element from A, an element from B. I'm going to go just in order. So I'm going to start with the letter A from A, and then the number 1 from B, and we're just going to then work from there. So here goes. I'm going to, in some parentheses, I'm going to put A, comma 1. Okay, I've got an element from A and an element from B. This is called an ordered pair. When you put parentheses and you got a little comma, it's like a little list. If maybe you have some bad algebra memories of graphing things, and if you remember your ordered pair, that's how far you went on the x-axis, and this is how far you went on the y-axis. Okay, that's how you probably have seen it in the past. That's the first element of the cross product. And now I'm just gonna go, and now I'm gonna, again, from set A, I've got A. And what's the next element from set B? 5. So I'm going to do A with 5. And you do that for every element. So I would do that, the little a with every element from B. If there was another element of B, I would just keep doing that, A, comma, whatever. But now I've run out. There's no more elements in B. So now I'm going to move to my next element. What's the next element in the set A? B. It doesn't really matter. You could do C. I heard somebody say C. It doesn't matter. I just like to be systematic because I will forget. Okay, so I'm just moving to the very next element instead of skipping to the end. So now I'm going to pair up the B with the 1, and then I'm going to pair up the B with the 5. Does anyone not see the pattern of what's going on? I'm taking an element from set A and then an element from set B in that order, and now I'm just going to do this till I exhaust all the possible combinations here. No, that's subsets. These are not subsets. Subsets of A would just be, if I was listing subsets of A, that would be things that just contain elements of A. So like the set with A, the set with A and B in it, the set with B and C in it. So notice these just have elements of the set A in it. That's a subset. Okay, we are creating a brand new set here with ordered pairs. So I'm plucking out the A and the 1, I'm jamming them together, making a new element in a new type of set. And so good thought, good question, but that's not the exact same thing that's going on here. So I've done the A with the 1, the A with the 5, I've done the B with the 1, the B with the 5. What's the next element in my cross product going to be? The C with the 1. Yeah, excellent, good job. And then the last one is going to be the C with the 5. And just like I said with the set B, if there was another element of A, if I had D, then I would do the D with the 1, the D with the 5. Just do it till you exhaust all the possibilities. And that's why I didn't create large sets, is because I didn't want us to be here all day. What I would like you to do then, okay, because the order matters for the cross product, I want you to flip it around. I would like you to do B cross A. So the first element of each ordered pair is going to be something from B, and the second element of the ordered pair is going to be something from A. I'm going to get started listing. If you have any questions or if you got something different, you don't know why, please just let me know. So I'm going to start with an element of B. So this time I'm going to go 1 and then A. So notice the order is just reversed, an element from B, then an element of A. Then I'm going to do 1 with B. Then I'm going to do 1 with C. And then I have nothing else I can pair the 1 up with, so I'm done. Now I move to the next element. I've got 5. So I've got 5 with A. I've got 5 with B. And then I've got 5 with C. Now, a question you might have is, hey, Mr. Perkins, I did that in a little bit of a different order. I've got 1 with C here, and then 1 with A, and 5 with B. And as long as you have those same 6 ordered pairs in your set, it doesn't matter what order they are in. The order pair has to be in the same, 1 in A, 1 in B, but it doesn't matter if you have them wiggled around a little bit. All right, last thing from this section. The last thing I wanna ask you is this. What's the cardinality of A cross B? How many elements are in that set? Sure, go ahead and answer. 6, yeah. There's 1, 2, 3, 4, 5, 6. I want to show you a relationship because this will come back. This will be very valuable for us later in the semester. How does that relate to the number of elements in A and the number of elements in B? How many elements are there in A? 3. How many elements are there in B? 2. How can you get 6 out of 3 and 2? You multiply, and that's the relationship. Okay, this will always hold. This will help us later. Actually, when we talk about probability, it's going to be called the counting principle. Okay, it's going to be a very useful tool for us, and we're going to take advantage of this very next thing that I write on the board. That the number of elements in your cross product is going to be equal to the number of elements in the first set times the number of elements in the second set. Where you just told me that the number of elements in A was 3, the number of elements in B was 2. 3 times 2 gave me 6, which was how many ordered pairs that we have. And that's always true. So this is a good little principle that will help you. And there'll be a couple of problems in the homework asking you to get familiar with that.